In this video, we are going to learn about interconnection of components. In the previous video, we have seen the functional components of a computer, and in this video, we are going to see the connections among those components. Interconnections of components. The functional components of a computer need to communicate with each other to perform a particular task. So, it is obvious that any component cannot complete the task without the interaction with any other component of a computer. Hence, we require the components to be connected to each other. Computer is a network of components. The collection of paths connecting the various components is called the interconnection structure. So, the way the components of computer are connected, how it is going from one component to the other component, this complete structure we refer it as interconnection structure. The design of the structure will depend on the exchanges that must be made among modules. So if you see, the memory will not be able to directly interact with input-output devices. So which module need to interact with which module, based on that particular interaction, this particular interconnection structure will be designed. First, we will see the input and output of a memory component. So, memory functional component we are considering. So, what are the inputs and what is the output of this particular memory component? So, it looks like this. It will have a read control signal, write control signal, address bus where we can provide address to the memory as an input, and data bus where we can provide the data as an input. At the same time, data bus as an output from which we can take the data. So there are two operations that can be performed using a memory component, that is read and write. So first, read. What is the inputs we are supposed to give if we want to perform the read operation? Enable read control signal. So first of all, we are supposed to enable read control signal. Then provide the address on the address bus where the data is to read. So we are supposed to give the address from where we are supposed to read the content from the memory. So here we are having 0 to n minus 1 words. Let me say 25th word I want to read. Then I have to enable this read control signal, and 25 should be given as an address. Then 25th data word that will be coming out of the memory. So output is data from the given address. Now if we want to perform a write operation, then inputs are first enable the write control signal, then provide the address onto the address bus to where data is to be written, and then provide the data to be written on the data bus. So the data what we want to write should be given onto the data bus, and into which address we want to write should be given onto address bus. Once write control signal is enabled, then the corresponding data will be stored into the corresponding address. No output will be there in the case of write operation. Now let us see how the read operation of a memory component is. So now this is the memory, and this is the corresponding data we are considering as a sample which is already existing in the memory. Now I want to perform a read operation. First give read control signal, provide the address from which we want to read the data. So address is 10. So from this particular address 10, that is this corresponding data should be as an output of this operation. So the data will be provided as an output. This is how the read operation of a memory component is taking place. Then comes to the write operation. First write control signal is given, then address, then data. So this data we want to write into the address 5. So directly it will store into the memory address 5 the given data. There will be no output generated in the case of write operation. Then comes input and output of an IO module. So IO module will be having so many inputs and outputs. Inputs, read and write control signals, address bus, internal data bus and external data bus will be, because this is having both input modules and output modules, will be having both read and write control signals. So here IO module can control more than one external device actually, that is using M ports, M external devices can be controlled. So each of the interface to an external device is referred as port. That is the reason why we say that M ports means M external devices can be connected. Each will be having a unique address 0 to M minus 1. Finally, IO module may be able to send interrupt signals to the processor. The interrupt signals is helping the CPU to understand that some IO device wants to interact with it. So that is the reason like why interrupt signals are there as an output for the IO module, which actually interacts with the CPU. So here if we want to go for read operation, give read control signal corresponding address, and then the internal data will be there. That is, if we are interacting with the internal devices, then internal data will be coming out. If it is working with the external devices, then external data will be coming out. So IO module will be able to recognize whether it is an internal device address or external device address. Suppose if it is a write operation, provide the address and corresponding data either in internal data or external data. Internal devices means computer system that is similar to your memory, and if it is external, it is mean that external devices are connected. Then comes to the input and output of a processor component, that is CPU. So here the processor will be having instructions as an input, data as an input and interrupt signals. Just now we have seen that interrupt signals will be coming from the IO module actually. Address, control signals and data will be the output signals for the CPU. So for the CPU, let us say if we are executing any program, then the instructions will be the input to the CPU, where it is decoded and then the operand address will be calculated. So their operand address will be the output of it. So which operation need to be performed, that will be generated as a control signals. So control signal will be generated to say which operation will be performed, and at the end, after performing the operation, we are supposed to get the result. So that result will be given as an output in the data, and obviously this data is the input on which the operation is being performed. So that is the reason why we are having instructions, data and interrupt signals as an input of a processor component, and address, control signals and data as output signals for CPU. Interconnections between these components, that is processor, IO module and memory. As we have seen in the previous video, the connections, the memory and the processor will be interacting with each other. IO module will be interacting with the processor. So we can say that the processor CPU is interacting with both the memory and IO. Actually, IO module will not directly interact with the memory, but this using DMA methodology, that is direct memory access, where we can make IO module interact directly with the memory without the interference of processor. So here in this video we have learned how different functional components of a computer interact with each other. Thank you.